Hello again. This is the second video for section 7.7, Advanced Geometry. In the first video, talked about the idea of solving a right triangle, which means you're figuring out what each side length is and what each angle measurement is. So, in this video, we're going to talk about given two side lengths. So if you know two side lengths of a right triangle, you can find the third side always by using Pythagorean Theorem. That's always true for any right triangle. But you don't know the two acute angles. And so in order to find those two acute angles, or at least one of them, I'm going to start with one of them, you're going to need to use the trig functions. But the normal trig function, you take the trig function of an angle measurement to find the ratio of those sides. We don't know the angle measurements, so we have the different thing. It is called an inverse trig function. So, the idea of an inverse trig function, all right, if I'm gonna look at angle C here. All right, I know the side 6 and the side 8. So, relating the angle C to side 6 and 8, 6 is the opposite, 8 is the adjacent, that's the tangent ratio. So, tangent of angle C would equal 6 over 8. Now, you really can't type that into your calculator. The calculator doesn't know what C is, it needs to know an angle measurement. So, the idea of an inverse trig function, I guess the idea of it really is just like you solve any problem. If you got 3 times x equals 5 and you want to know what x is, that's a 3 multiplied by x. We need to get rid of that multiplying by 3, so we divide by 3. So multiplication and division, they're inverses of each other. They cancel each other out. Okay? Just like addition and subtraction. You got x plus 3 equals 5. We want x by itself, so we got to get rid of that plus 3. Subtract 3. Okay? The adding and subtracting are inverses of each other. They undo each other. Okay, we're going to apply that same thought process to these trig functions. Okay? We're going to take the tangent of angle C to equal this ratio of 6 over 8. We need to figure out what C is. So we need to get C out of this tangent function. Well, if you take the inverse, and that's just, it's not an exponent, this little -1 here, it's written in the exponent position, but it has really nothing to do with exponents at all. It's strictly notation. If you take the inverse tangent of the tangent of angle C, so basically we're doing the same thing on both sides. We're going to take the inverse tangent of 6 over 8. Okay, the inverse tangent and this tangent, they cancel each other out, just like multiplication and division canceled out over here, just like adding and subtracting cancels each other out, as long as it's the same trig function. So the inverse tangent of the tangent of angle C is just angle C. So angle C equals the inverse tangent of that ratio, 6 over 8. This is the idea of how we're going to solve for one of those acute angle measurements. We're going to use these inverse trig functions. Okay? It works exactly the same thing with the sine function and the cosine function. You just have inverse sine, inverse cosine. So which one do you use? Just like before, it depends on what sides you know and what angle you're dealing with. So you're going to use that proper ratio. Sine is the opposite over hypotenuse, cosine is the adjacent over hypotenuse. Whichever one sides that you have and the angle you're looking for, that's how you determine the trig function. So, to solve for angle C here, just like always, anytime you're dealing with the trig functions, we're going to go to degrees in the mode. Then, if you hit the secondary button and the tangent button, you'll see it says tangent -1. That's the inverse tangent function. Type in your ratio, 6 divided by 8. Close that parenthesis, hit enter. The measure of angle C is 36 point, and we'll go to the nearest hundredth. So that would be 87 degrees. There's angle C. Okay, so we're using inverse trig functions to calculate one of those angle measurements. Once we know one of those acute angle measurements, 36.87, to find angle B and angle C are complementary. So 90 minus 36.87 That is going to be 53.13 degrees. Okay. And just for giggles, to find angle B, let's throw some more information in here. We're trying to solve this right triangle. So Pythagorean Theorem, 6 squared plus 8 squared equal the hypotenuse squared. Hypotenuse is 10. So to find angle B, let's say we didn't just calculate it. I know side 6, and I just figured out the side 10. So angle B in relation to side 6 and 10, 6 is the adjacent side, 10 is the hypotenuse. That's the cosine. So cosine of angle B would equal that cosine ratio, 6 over 10. So that means angle B is going to be the inverse cosine of 6 over 10. So this is the idea of these inverse trig functions. Whatever angle it is you're looking for and what side you know, that trig functions ratio tells you, oh, I got to be using this one. So we go secondary, cosine. There's your inverse cosine function. 6 divided by 10, enter, 53.13 degrees. That's exactly what we said it was the other way. All right, this is the idea, excuse me, this is how we're going to use these inverse trig functions to solve right triangles. All right, so let's do some examples here. We'll start with number 5. So Pythagorean Theorem, we're going to do 11 squared plus 18 squared to equal, we'll call this side C, equals C squared. So I'm just going to go to my calculator. 11 squared plus 18 squared, enter, and take the square root of that. Okay, side C is 21.095. So I'm going to decide, doesn't matter which angle you find first, I'm going to go with angle P. Now, because we know all 3 sides of this triangle, pick a trig function. It doesn't matter. We did tangent and cosine in the last screen, so I'll do sine. The sine of angle P is the opposite over the hypotenuse. Okay, so when I do these inverse trig functions, always going to set it up the exact same way as if we knew the angle, like it's shown right here. Sine of angle P equals that ratio, opposite over hypotenuse. To solve for angle P, that's our inverse trig function. So the inverse sine of that ratio. And so just go to the calculator. Secondary sine 18 divided by 21.095. Enter. Measure of angle P is 58.57 degrees. Once you know one of those acute angles, you can figure out the third one very easy. 90 minus the answer we just got, there's angle N, 31.43 degrees. We know all 3 sides, we know all 3 angle measures. We have solved that triangle. Okay, this second example, again, you're going to do Pythagorean Theorem to find side UT. Let's say you just you're getting into the mode of the trig stuff and you just forget to find side UT. So, and we just want to start finding these angle measurements. Let's go with angle U first. That side 7 is the opposite leg. The 23 is the hypotenuse. That's the sine ratio. So the sine of angle U would equal 7 over 23. That means angle U equals the inverse sine of 7 over 23. To find angle S, again, you could just do like we did, complementary angles. Or if we're looking for for angle S, this angle here, the side 7 is the adjacent, 23 is still the hypotenuse, so that would be the cosine ratio. Cosine of angle S equals 7 over 23. So to find the measurement of angle S, you do the inverse cosine of that ratio, 7 over 23. Okay? And you can do that third example on your own. Try it out. When you get into class, ask me and I'll take a look at it and see how you did on it. But this is how we're solving right triangles. When we don't know any of those acute angles, inverse trig functions, that's what they do. They find an angle measurement as long as you know the proper ratio for that trig function. Okay? SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangents opposite over adjacent. That's it. Have a good day.